Hello students, today we are going to discuss about the preparation of aldehydes, especially naming reaction we are going to see. In that, Rosenmund reduction, Stephen's reaction, selective reduction. These are the three main things we are going to check. The first one, Rosenmund reduction, that is we are getting acetaldehyde through acetyl chloride. Second one, Stephen's reaction, that is through cyanohydrocarbon, that means cyanide. Third one, it is diisobutyl aluminum hydride, that is actually a reducing agent. Through that we are getting acetaldehyde. This is something different. We are going to see to that. Okay, now this is acetyl chloride, CH3COCl. Actually, from here it is called acetyl. Okay, in this OH group replaced by Cl. So, this is acetyl chloride. Okay, so this is a acetic acid derivative we can say. In that, acetyl chloride is heated with hydrogen in the presence of palladium and barium sulfate as a catalyst. We are receiving what it is? CH3CHO. Okay, now how do we get? A simple idea I'll give you. This is a hydrogen, no? Just here one hydrogen, here one hydrogen. So automatically CH3CHO, here what it is? HCl. So this is the product acetaldehyde. So this is called Rosenmund reduction. Okay, in this catalyst we are using what it is? Barium sulfate. Palladium and barium sulfate. Why do we use these two catalysts? One is promoter. Palladium is a promoter and barium sulfate is a barium sulfate is a catalytic poison. Why we are using catalytic poison means usually this acetyl chloride or acid, whatever it may be, acid or acid chloride. Its common name acid chloride also we can say. So it is reduced. That means adding hydrogen, it is called reduction, isn't it? So it is reduced to acetaldehyde. And it's further reduced to primary alcohol. So, to avoid this step, we are using barium sulfate. So, in this, they may ask in a different question, why do we use barium sulfate in Rosenmund reduction? So, what is the role of that barium sulfate compound for this Rosenmund reduction? In such a way also they may ask. So, acid chloride is reduced to acetaldehyde and it is to avoid further reduction to get to primary alcohol. For that sake, to avoid, they are using what it is? Barium sulfate. So this is the one. And second point, what it is? See, in this, what are the things we are going to get means? In this method, formaldehyde and ketone, these two compounds we cannot prepare by this method. So these are the 2 points important. First point, why do we use barium sulfate as a catalyst? This is used to avoid, to further reduce to get primary alcohol. The second point, with this method, with this Rosenmund reduction method, we cannot receive the product of formaldehyde and ketone. So they may ask such kind of questions. Okay, one more method, it is benzoyl chloride. From benzoyl chloride, we can receive benzaldehyde. That is nothing through Rosenmund reduction. So what are the things we are going to? It is reduced. That means benzoyl chloride is treated with hydrogen in the presence of palladium and barium sulfate, we are receiving benzaldehyde. The same, it is aliphatic and this is aromatic. These are the two main steps. They may ask what is the Rosenman reduction or how do we get the aldehyde from Rosenman reduction, or what is the role of barium sulfate in the Rosenman reduction reaction. Like that, such kind of questions they may ask. The second method is Stephen's reaction. Stephen's reaction, what compound we are using? It is a cyanide compound, cyanohydrocarbon. We can say it is a cyanohydrocarbon. It is a cyanide compound. Through cyanide compound, we are receiving the acetaldehyde. How do we get? Come on, let us see. It is methyl cyanide, CH3 C triple bond N. Okay, in this reduced, here also reduction reaction only. So methyl cyanide is heated with that hydrogen in the presence of stannous chloride, okay, and HCl. So when we are treating with this stannous chloride and HCl, we are getting what it is. See now, here hydrogen is there. No, here actually what we are going to receive, it is a imine compound. Amine, we have heard about that. NH2, it's amine we can say. But imine, what it is? See, now this hydrogen is going to attach over here. That means it's breaking one bond. It's breaking one bond, and here one hydrogen, here one hydrogen. So what we are going to receive? It is CH3, CH double bond NH. So this compound is called amine. CH double bond NH, it is called what it is? Amine. So it is further hydrolyzed, this compound, it is further hydrolyzed. Hydrolysis takes place. Okay, what we are going to receive, see here, now in this the compound it breaks, that means the bond it breaks, here H2, here O. So CH3, CHO, that means what it is? CH3, CHO, it is called acetaldehyde. Then here NH, here 2H2 is there. So altogether it is NH3. It is ammonia. Okay, so what it is? Acetaldehyde. Okay, so methyl cyanide is heated with hydrogen in the presence of stannous chloride, tin chloride. Also we can say with HCl. We are getting a amine, that is an intermediate compound. Then further hydrolysis takes place. There we are getting acetaldehyde. In this step, easy method. See, here triple bond is there. That bond breaks both the side hydrogen. You are getting CH3, CH double bond NH. So CH3, CH double bond NH. It is called imine. Okay. Now it's further hydrolyzed automatically. Here hydrogen H2, here also bond breaks. So automatically you are getting a acetaldehyde over here. Here ammonia. Hope you got that. Okay, the next method, it is selective reduction of cyanide. Here also we are going to check from cyanide only. Cyanide means it is a nitrile compound. Here what it is? Methyl cyanide. Methyl cyanide. Okay, now here we are going to get a different cyanide compound only, but unsaturated cyanide compound, that means double bond compound, that means alkene compound also will be coming. Let me write this so you will come to know. CH3, CH double bond CH, CH2, CH2, C triple bond N. Okay, so C triple bond N, naturally it is a cyanide compound. In this IUPAC name, we can write it is what it is, nitrile. Nitrile. Okay, now this is a nitrile compound. In this, how many carbons are there? 1, 2, 3, 4, 5, 6. Through numbering, we can give the name. I've told you, no? So, 6 carbons are there. In that, which carbon double bond is there? 1, 2, 3, 4th carbon. That means 4 ene. Okay. Then, how many carbons are available? Hexa. 4 ene nitrile. So, what is the compound name? Hexa 4. This is 1, 2, 3, 4th carbon only ene, that means alkene compound is there. So 4 ene nitrile compound, hexane formula. Okay, now come to the point. With this, reduced with what it is? Diisobutyl aluminium hydride we are using. So with this, what we are going to receive? This is also reducing reaction. That means reduction reaction only. No. So hydrogen is always will be there wherever reduction takes place. So what happens? The same thing it will happen. This bond breaks. This bond breaks, here one hydrogen, here one hydrogen, these two hydrogen, H2 is there, no? So here one. So whatever CH double bond NH, it is a imine compound. So how can you write the same formula? Same thing you will write. Instead of that, the bond breaks, CH NH. You will write it in such a way. CH3, CH double bond CH, here CH2, CH2, here no place, I'll write it here, CH double bond NH. I will write it in here so that you will come to know very clearly. CH3, CH double bond CH, CH2, CH2, CH double bond NH. So CH double bond NH, it is called what it is? Imine compound. Okay, what is the speciality of this reaction? What is the speciality of this reaction is actually, why do we use this reducing agent? Diisobutyl aluminium hydride. What is the purpose we are using? Actually, what is the purpose? You know, this is the selective reagent reduces only a polar multiple bond. What is a polar multiple bond over here? It is cyanide only. It's a polar multiple bond. So what is non-polar multiple bond? Non-polar multiple bond, it is actually what it is? Same compound, that means C double bond C. It's a non-polar multiple bond. C triple bond N. This is a polar multiple bond. Polar, non-polar. In 11th standard only you might have learnt about that. See, C double bond, same molecules. Same molecule means it is a non-polar. It is a C triple bond N, both are different, so it is naturally a polar molecule. So to break the polar molecules bond only, we are using what it is? Diisobutyl aluminium hydride. For that purpose only, this is a reagent which is using for the reduction to break the polar bond. Polar multiple bond. For that purpose, we are using. But this reagent, that is diisobutyl aluminium hydride, will not disturb this bond. For that purpose only we are using. Only to break the cyanide compound only we are using what it is? Diisobutyl aluminium hydride we are using. And this reagent will not break the non-polar bond. In the board question, they may ask directly selective reduction of cyanide reaction. Explain it, they may ask. Or what is the purpose they are using to get that what it is, to get the aldehyde, why do we use diisobutyl aluminum hydride? That is also, actually this is a intermediate compound. Still it is further reduced with what it is. Here hydrolysis takes place. Hydrolysis takes place. Here what we are going to receive, the main compound. What is that main compound? That here actually hydrolysis means H2O. No? So here again the bond breaks. So again bond breaks means here O, here H2. So what is that product we are receiving? The same CH3. Okay, now in this we are going to receive this compound, that is actually what it is, CH3, CH, double bond CH, CH2, CH2, CHO. Here I have told you, no, through hydrolysis the water molecules will break this double bond. Again we are getting a aldehyde. So what is the name of this? Hexacarbon. The same carbon will be there. Instead of that NH, CHNH imine compound, it breaks and we are getting a aldehyde, and then ammonia we are receiving. So this is one of the important question. They may ask different way, they may ask the question. What is the purpose they are using diisobutyl aluminum hydride? What is the role of diisobutyl aluminum hydride? Give one example of polar multiple bond reduction. Like that way they may ask. So you just go through that thoroughly. Hope you got it. This is a diisobutyl aluminum hydride. A simple way I'll tell you. Diisobutyl aluminum. Diisobutyl means what it is? CH2C. See here also you can say CH3, CH, CH3, CH2. So both the side what it is? Diisobutyl. Here aluminum it's a divalent. Here it is a divalent. Sorry, aluminum is a trivalent. Here actually diisobutyl aluminum hydride. Here it is, one more thing it is there. So this is the structure of diisobutyl aluminum hydride. 2 more question or 1 more question, fill ups or choose the correct answer. Anyway they may ask.